Howdy, section 5.2 is direct variation. It's the simplest type of variation when you get to your upper level math and science classes. You talk about variation a lot in indirect and all different kinds there. But this is just direct variation with two variables. So it's not bad, and that's why we start with Algebra 1. So a direct variation equation looks like this, y equals kx. It looks like slope-intercept form of a line, but there's no y-intercept. There's always the y-intercept is always 0. And you just have some multiple of x. So k, in terms graphically, is the slope, or the rate in which these two variables affect each other. Okay? So if I look at a graph of a direct variation, it's always going to go through the origin. So that's 0, 0. It's always going to go through the origin. And it will have slope k. So however you want to draw that, and the slope is k. I'll just say there. Okay, so if k is large, the slope is large, it'll go very quickly. K could be negative, so it'll be going down. Whatever that value of k is, that's your slope. Okay, so if I look at a couple of equations, are these direct variations? The textbook type thing to do is to solve them for y, but then we'll tighten it up a little bit here in a second. So let's solve this for y, and I get y equals 2 over 7x. Okay, I had 7y equals 2x. And here I have it written now that y is a multiple of x. So I would say, yes, this is direct variation. Okay, there's no additional constant there at the end. Next, I'm going to solve this one for y. And I know I'm going a little fast. I'm going to chat about them in a minute, so I'll give you a minute to catch up on that. So if you subtract the 7x over, you get 3y equals negative 7x plus 8. Sometimes writing all the, we're kind of graduating from writing all the steps in there. So if you're moving the 7x to the other side of the equation, we'll just make it negative. We subtracted 7x on both sides to move it over. Okay, so we can speed that up a little bit. And then we'll divide by 3. And I'll just cross that off there. So you can see y equals something times x plus something else. So this is not direct variation. Okay, and going back, you know, the y-intercept has to be 0. So if you put in 0 for x, you should get 0 for y. If you look at this first equation, that happens, yeah, well, the x is 0, and then y would be 0 because both sides have to be 0. That's not true here. If you have an additional constant just hanging out that doesn't cancel out with anything, then it's not direct variation. So just looking at the equations, because both the terms have a y or an x on it, that's direct variation. Over here I have a constant left over, so it's not direct variation. Some of the examples in the textbook are a little tricky though, because it'll write something like 4 minus 4, and those cancel out. So don't just, if you see a number, just jump directly to it. You know, simplify a little bit first if you can. Okay, I got a little ahead of myself with this next one. Maybe I can get a piece of paper real quick. Here we go. Yeah, I don't want to give too much away. So it says let y vary directly with x, and y equals 15 when x equals 5. So if you're given instructions like this, well, let's write out the direct variation equation. Okay, no constant at the end. Plug in 15 for y and 5 for x. And then solve for k. Well, k is going to equal 3 here if I divide by 5. So this equation is now going to be, draw a little arrow there, y equals 3, whoops, 3x. Beautiful. So if it says let y vary directly with x and to give you some numbers, you can find the value of k by doing that. Just plug them into y equals kx, solve for k. It should just be a step or two tops. All right, finally, one more thing, and then we'll do a couple problems together. I'm asking you, is this a direct variation? Now, remember the value of k is like the slope, so that's the y over the x. So let me put a note here. K equals y over x. And so to tell if this is a direct variation, we find the value of k for each row. So I'm going to expand this table. We'll say, hey, let's check about k. Okay, so y divided by x. So 15 divided by 3, that's 5. 25 divided by 5, that's 5. And 36 divided by 6 is 6. Well, that's not a constant, so I would say no. So, if this was the same number each time, I would say yes, direct variation, and k is that value. If it's not the same each time, we're just going to say no. No, 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 no. No. And that's all we can do there. Okay, on page 302, let's do the lesson check, just problems 1 through 4. Go ahead and try those out.